Hello friends, this is Gangadhar from the YouTube channel Maths Ganga. So in this video I am going to discuss the questions of RMO 2018 and the question numbers are like 17, 18, 19 and 20. In the previous videos already I discussed the first 16 questions and in the coming videos I am going to discuss the remaining questions. Okay, do subscribe for the channel and share it for your friends and get help and give some help for them in their preparation, right? So now coming to here, the 17th problem of RMO 2018 for this question, a geometry problem. So very simple. If you observe, see it is given that triangle ABC and triangle DEF. The problem is about two triangles, and they mentioned that angle A and angle D are equal. AB is equals to DE is 17. BC EF is equals to 10. AC minus DF is equals to 12. With all these instructions, we need to frame a diagram. And from there we need to calculate AC plus DF. Usually, as they mentioned here, triangle ABC and triangle DF, usually the students try to draw two different diagrams for ABC and DF, and they try to show whether they try to connect those two triangles with certain congruency or with similarities. Okay, see if you observe, as they mentioned, two sides are equal. Okay, like ABBC, DEF, but angle B and angle E are not equal. So those two triangles are not congruent by SAS congruency. Okay, why? Because we don't have SSA congruency. Two sides are equal and one angle are equal in these two triangles, but those two triangles are not congruent. Okay, so for that what I am going to do is, since angle A is equals to angle B, initially we just take an angle. Okay, this is an angle. Okay, right. So this angle is both A and D as well. So this point may be A or may be D. And they mentioned that AB is equals to DE is equals to 17. Both are same, AB and DE. So take a point B here, such that this length is 17. Also DE is 17. You also mark it as B. Okay. So we call this point as either A or B and this point as either B or D. And the length AB is and DE as well 17. Now BC is equals to EF is equals to 10. BC is 10 as well as EF is also 10. See, we need to draw BC and EF. C and F are not equal. C and F are two different points. Okay. So BC is 10 as well as EF is 10. And they mentioned that AC minus DF. See, for our contest, A and D both are same. So I can replace this DF also with A. So AC minus AF is equals to 12 I have. And I am going to calculate AC plus AF. Okay, AC minus DF is given, AC plus DF they asked. Okay, now since AC minus AF is 12, C and F are not equal. If C and F are equal, coincident, then AC minus AF is 0 now. So for that, to make two different points C and F on this ray, okay, since they mentioned BC is equals to AF is equals to 10, what I do is, okay, for suppose B is, I am going to draw two lines with the length equals to 10 from this P. Okay, just like this. Okay. Or suppose you just took yes, I am going to change the diagram for our convenience. Okay. This is B or E and this total length is 70. Okay. See, they mentioned that these two are equals to 10, 10, 10. Okay, BC, AC minus AF. What will you take? Which one is larger? AC is larger and AF is the smaller. So BC is 10, AF is 10, EF is 10. So BC and EF are equal 10 and 10. And also they mentioned what? AC minus AF is 12. This is total length AC minus AF, and as they mentioned, this length is 12. Now, clearly this is an isosceles triangle 10, 10 and 12. So if you draw a perpendicular from this vertex to the opposite side, okay, if you draw a perpendicular, since it is looking like an isosceles triangle, it bisects the opposite side. These two lengths are 6 and 6. Since this is 10, this is 6, then by the Pythagorean result, this length will be 8. 8 square plus 6 square is 10 square. Now, what I am going to calculate AC plus AF. So it is very clear if you concentrate on these three vertices. Okay, this length is 17, this length is 8, and I have 90 degrees here. So So this 8 and this 17. Okay. For 17 and 8, if you again using Pythagorean triplet, you will get this length as 15. From A to this point, the length is 15. Okay. 8 square plus 15 square is 17 square. Since this length is 15, what we need to calculate? We need to calculate AC plus AF. Since this length is 15 and this length is 6, from A to C, 15 plus 6, 21 is the length. And from A to F, the total length is 15 and just subtract 6. 15 minus 6 is 9 and AF is 9. So AC plus AF is 30. So there is the problem. Okay. So the problem is for a suitable diagram. And the next task is we need to identify two Pythagorean triplets, one with 6, 8, 10 and the other one with 15, 8 and 17. There is the problem. Right. Then coming to the 18th problem of RMO. The problem is of usually number theory. A, B, C is given as greater than or equals to 4. Okay. And A, B, C are integers. Since they are greater than 4, they are integers, usually naturals. And they mentioned that 4ABC is equals to A plus 3 into B plus 3 into C plus 3. Okay. And we need to calculate the possible value of A plus B plus C, the value of A plus B plus C. So if you look here, this is 4ABC and this is A plus 3 into B plus 3 into C plus 3. Since the left side is a 4 multiple, the right side must be a 4 multiple. How the right side will be 4 multiple? It is possible in two ways. One way is any two numbers are even. If any two are even from this side, okay, automatically it becomes a 4 multiple. Okay. And the other case is if one number is 4 multiple, then it is a 4 multiple on both sides. So with that idea, I am going to replace A with a suitable number such that A plus 3 is a 4 multiple. Okay. If you take A as 1, 1 plus 3 is 4. But A is given as greater than or equals to 4. So we can't take 1 in the place of A. So what I will take on the next one? 1. If I replace this A with 5, 1 is not possible, so I took 5. So if I replace A with 5, 5 plus 3 is 8, then both sides are 4 multiples. So if you replace with 5, I have that I am going to replace A with 5. 4 into 5 into BC is equals to 8 into B plus 3 into C plus 3. Now if I cancel 4 2's. Now if you look, the left side is a 5 multiple, 5BC. So to make the right side also as 5 multiple, I have to replace this B or C. So for our convenience took B. So if you replace B with 2, 2 plus 3 is 5. But 2 is not possible because A, B and C are greater than or equals to 4. So take the next number, like 7. If you replace B with 7, 7 plus 3 is 10. So the right side also becomes 7 or 5 multiple. So replace B with 7, 5 into, okay, 7C is equals to 2 into 10 into C plus 3. Now, what it is? 5 2C is 10. And now 7C is equals to 4C plus 12. On calculation we have that 3C is equals to 12, C is equals to 4. So the possible values of A, B, C are A 5, B what is 7 and C is 4. So A plus B plus C. 7 plus 5 is 12 plus 4 is 16 and the value of A plus B plus C is 16. There is the problem. Okay. So how we did? Since the left side is 4 multiple, to make the right side as 4 multiple, I replaced A with either 1 or 5 like that. Since 1 is not possible, I took 5. Then in the same way, I took 7 in the place of B to make both sides as 5 multiples. And then directly I got the value of C as 4 and the sum of the values of A, B and C is 16. There is your answer. Right? Then coming to the next problem. 19th problem of RMO 2018. So if you go to the 19th problem, the problem is from the sequential series. What it is given, if you look, see n is equals to, for the 19th problem, it is given that n is equals to 6 plus 6 6 plus 6 6 6, like that you need to continue, plus 6 6 6 6 6. As they mentioned, this last term contains 100 sixes. Okay. The question is, how many times does this digit 7 occurs in the number n? after simplification. How many times the digit 7 occurs in this simplification? See, how can we do? So usually we come across with this type of problems in usual board examinations and in different competitive examinations also. How can we do? So n is equals to, if you just common out 6 and then if you common out 6, what we have? 1 plus 1 1 plus 1 1 1 plus and so on, 1 1 1 like that. And then divide with 9 and then multiply with 9. We have that 6 by 9 into 9 plus 99 plus 999 plus and so on plus 9999, 100 times of minus. Okay, and then see, I am writing this is 6 by 3. This 6 by 9 is nothing but 2 by 3, and I will write this 9 as n minus 1 and 99 as n square minus 1. Like that, if I continue, since it contains 100 nines, 10 power 100 minus 1 I have. Now I need to add all these things. This is 10 by 3. And here if you observe 10, 10 square and so on 10 power 100. They are forming a geometric progression whose initial term is 10 and the common ratio is also 10 with 100 terms. Then what we have to do? Initial term a into r power n, 10 power n 100 minus 1 divided by r minus 1, n minus 1. Sum of n terms of the geometric progression minus 1 1 1 1 like that, we have 100 ones, so minus 100. We need to simplify it. See, if you come out 10, what we have? See, 20 by 3. So we need to simplify it. This is 10 minus 1 is 9. 10 power 100 minus 1 is, again, that is 9999 like that, 100 times. So what we have? So we need to simplify it. If you simplify, this is equals to, just you common out 10. 20 by 3 into, just look here. 10 power 100 minus 1. 10 power 100 minus 1 is nothing but 100 nines like this. That value is divided by 9. So automatically what you get? You will get once. Okay, 100 times minus 10. So 1 1 1 1 like that, 100 times minus 10. So what we have? 1 1 1 1 1 like that, 1 1 1 minus 10. So we need to subtract. 1 minus 0 is 1. 1 minus 1 is 0. And then 1, and then 1, and then 1, and then 1, like that you have ones. So totally how many ones you have? 98 ones along with 0, 1. Okay, so your answer here it is 20 by 3, okay, into this type of number amount. 1, 1, 1, 1, 1, 1, 0, 1. We need to multiply with 2 along with 0 and we need to divide with 3. Okay, what will happen? Since if you multiply with 20, then it becomes like, okay, this 0 comes to last and then we are multiplying with 2, 2, 2, 2, 2, 2 like that, 2, 0, 2, 0 divided by 3 is your answer. And if you divide with 3, what will you get? 3 sevens is 21 and then 1, 2 is 4. So there, after break again, 3 sevens is 21, 1, 2 is 12. For 3 2's, there is a break, so 740. And again for more 3 2's we will get 740. And again for more 3 2's we have 740. Like that if you contain, and the time you have that for 3 2's 22020. At the end if you divide with 3, 3 sevens is 21. Okay, and then we have the 10. 10 in the sense 3 3's is 9, 3 4's is 12, 0, 7340. So if you count the number of sevens, totally you will get 33 sevens in this expansion. Okay, so that is the way of simplifying the given problem. See, initially it's a usual sequence problem, and after that the simplification is the additional work for this problem, and at the end you will get 33 sevens in the result of that. So this is a 19th problem of RMO 2018. Okay, then the next one is again from the number 3, 20th problem. If you observe the 20th problem, okay, very different one. Okay, right, it is given that determine the sum of all possible positive integers n, the product of whose digits equals to n square minus 15n minus 27, n square minus 15n minus 27. Okay, so what it is mentioned here? right? N square minus 15n minus 27. We have a number. Okay, see, first of all try to understand the question. So n is a number. Okay, there are certain digits in n. If you multiply all the digits of n, that product of the digits is equals to n square minus 15n minus 27. That was the question. We need to count the all possible values of n, and we need to add sum of all those possible positive values of n. Okay, sum of all those possible values of n. What is the question? N is a number having certain number of digits. If you multiply all the digits of n, the product of all those digits is again equals to the number. So n square minus 15n minus 27 is given as product of digits of n. Product of digits of n. So to satisfy this particular property, this particular rule of n, we need to find out the values of n. After that, we need to add all those things. That was another part. See, first class case, what I am going to do is this n square minus 15n minus 27 is the product of the digits. Since the product of the digits is always positive, so first idea is n square minus 15n minus 27 is always greater than or equals to 0. Sometimes maybe 0 if any digit of n is 0. So okay, so n square minus 15n minus 27 is greater than or equals to 0. So to restrict n, what I am going to do is n into n minus 15 minus 27 greater than or equals to 0. Now, one simple idea is minus 27 is always negative. Since minus 27 is always negative, see, I am going to subtract the n's the values of n which are making the whole expression as negative. What I think is if you replace n with like 13 or 12, 12 minus 15, 13, n is clearly a natural number, right? Since n is a number, so 12 minus 15, 13 minus 15, 14 minus 15, everything is negative here. If you replace n with a number less than 15, it is also negative. Negative and negative, totally negative. So if n is 15, minus 27 also negative. So there is no chance of taking any number which is less than 15 in the place of n. So check from 16 onwards, right? So if you take 16, what is happening? If you take n is equals to 16, okay, then 16 into 16 minus 15. That was 1. 16 minus 27, again negative, so 16 also not possible. If you take 17, what happens? 17 minus 15 is 2. 2 into 17 is 34 minus 27 positive, so 17 is okay. So from there onwards you will get any value in the place of n. Okay, up to 15 not possible. Okay, and then just I check it for 16. After that everything is possible. And another idea is we need to keep in our mind that always product of the digits, okay, always product of the digits is less than or equals to the number. Okay, this is a very basic idea. Try check. If we need to prove it also. Okay, with the usual simple logic, we can prove that product of the digits is less than or equals to n. Okay, first of all, you just keep in your mind that product of the digits is less than or equals to 1, and I am going to solve this problem. And afterwards, in some other video, I will give you the proof for that also. Since the product of the digits is less than or equals to n, always it will happen. Product of the digits of a number is always less than or equals to the number itself. Okay, right. What is the product of the digits here? N square minus 15n minus 27 is less than or equals to n. So if you say n this side, n square minus 16n minus 27 is less than or equals to 0. Again I am going to restrict n. So n into n minus 16 minus 27 less than or equals to 0. This must be negative. So whenever it will be negative. Okay, see, whenever it will be negative, if you observe, if you replace n with some 15 minus 16 is minus, so negative. Okay, and then if you take, see, 16 minus 16 is 0, negative. If you take 17 minus 16, okay, see, we have the possible values of n as like this, and then try to check for that. Okay. And one more idea is n into n minus 6, n into n minus 16 minus 27 equals to 0, or in some other case we just multiply with minus sign and make it as positive to restrict n, nothing but. Okay, so if you want n into 16 minus n plus 27 greater equals to 0. Since this plus 27 is always positive, we need to make it as also positive. To make it also positive, 16 minus n must be positive. 16 minus n must be greater than 0. That means 16 must be greater than n. Okay. So usually if 16 minus n is positive, okay, that is positive. And in some other case, if this value is less than 27, then also positive. Okay. See, the value of n must be as it is given that the value of n must be less than 16, but if this value is less than 27 then also positive, what I am going to tell you is n into 16 minus n plus 27, whenever it is positive, check with 17. If you replace 17 into 16 minus 17 is minus 1 plus 27, they are equals to 0. This is star. Whereas if you place 18, 16 minus 18 is minus 2, 18 it is there, minus 36 plus 27. So if you replace n with 18, this is also not possible. So in both the cases, the situation is okay when the value of n is 17. So finally what I am going to conclude is our value of n is 17 only. No other possibility is there. See, check whether the situation is okay or not. If you replace n with 17, what is happening? If you replace n with 17, product of the digits is 7 in the right side, and whereas in the left side also, if you replace n with 17, this is only the expression now. If you replace n with 17, 17 minus 15 is 2, 2 into 17 is 34, 34 minus 27 is 7 itself. Okay, the problem is okay. So the one and only one possible value of n is only 17, and your answer is 70 itself. Okay, so this is one of the tricky problem of the RMO 2018, and the problem is from the number 3. Okay, so for this problem we need the passion towards the problem to solve. Okay, and then somewhat logical ideas, and then the way of procedure to solve the problem. Right. So these are the 4 questions from the RMO 2018. Okay, thank you. Do subscribe for the channel, and the next videos I am going to give you the solutions for the other problems.